Hello everyone. In this video we're going to be talking about multiplying and dividing numbers in scientific notation. So as I promised, here's the video that you asked for. Anyways, so first we actually have a multiplication of two numbers that are written in scientific notation. So as you can see, it's a number 2 point something times 10 to the power of something, and then all multiplied by another number which is 1 point something multiplied by 10 to the power of 2. And then this second one is about division, so we're gonna get into that also later. Okay, so let's start with the first example. So it's multiplication. So in multiplication, it's kind of, I would say, easier, right? So first thing, what you're going to do is this. So first, I'm gonna actually highlight the powers of 10. So we have 10 to the power of 3, 10 to the power of 2, okay? So in my opinion, the best way to do this is like this. So actually I will write it somewhere, like I will write it here, okay? So imagine you have 10 to the power of 3 multiplied by 10 to the power of 2. Okay, so we know that if you multiply two things with the same base, so we have 10, and then they have a exponent, a power. In multiplication, we add those powers, so it becomes 10 power 3 plus 2, or in other words, just what? 10 power 5, okay? So these two together, you can join them and just write 10 to the power of 5. So you add 3 with 2, okay? So that's actually the easy part. However, since you multiply these two, so now you have to actually deal with the real numbers themselves. So you actually write it down again. So I actually prefer that you write it down again. So we haven't changed anything. So 2.88 times 1.2. By the way, this is not the variable x, I mean multiplication here, okay? So now we're done with this part, yeah? So we have to multiply 1.2 with 2.88. Okay, so if you're good at mental math, you can do it quickly, but if not, you can always use the normal multiplication method. So 1.2, 2.88. Okay, so we're gonna multiply this. Although I prefer you remove the point so that you don't get confused. I will tell you a way to do it at the end, like where to put a point. But what matters here is that 2 times 8 is 16, so 6, then 1, right? 2 times 8 is 16 again, plus 1, so 17, so 7, and then 1 here. 2 times 2 is 4, plus 1 is 5 actually, so like this. So we're done with the first row, so we actually add a 0. And then 1 times 8 is 8. 1 times 8 is 8 again. 1 times 2 is 2, okay? So add these together. 6 and 0, that is just 6. 7 and 8, 15, so 5, 1. 1 and 5, 6. 6 and 4, and 8 is just actually 14, yes, 14. 4 and then 1, okay, and then 1 and 2 is just 3, okay? So this is the multiplication of these two numbers. However, we know that they both had points, okay? So you might be asking yourself, well, where should we put the point? Well, look, I have one number at the right side of the point, or let's say after the point, and then here I have two other numbers after the point. So overall, altogether, I have 3 numbers after the point. So I have to put the point so that, again, I will have 3 numbers after the point, okay? So the result of this multiplication is actually this number, okay? So 3.456, and don't forget about the 10 to the power of 5. And you just leave it like that, since we know we want actually another scientific notation number, like in the scientific notation. Okay, so this is the result for that. However, in sometimes you might end up with the point being somewhere else. you have to also move that back to there, okay? But in this example, that's the solution. Okay, for division, it's kind of similar, but instead of multiplication, you do division. Okay, so first, the same way we did for multiplication, you do the thing for the powers of 10. So as a reminder again, the same way we had a rule for multiplication, we actually have that also for division. So this time, instead of adding the exponents, we just subtract them. So 10 to the power of 5 becomes what? 10 to the power of 5 minus 10 to the, or let's say minus just what? 3. Or you can immediately say this is just 10 to the power of 2, okay? So you can actually remove these and just write what? 10 to the power of, yeah, so that was just to demonstrate the rule. But here we have 4 minus 2, okay? So 4 minus 2, which is again just 2, okay? So these two together, you just subtract 2 from 4. So you have 10 to the power of 2, like this. Okay, and then you can just write this again the same way. So 3.21, 1.07. So the same way we did for this, you just do the division this time and then write the result, okay? So actually, I will leave some space for that and erase this. Okay, so as you guessed it, yes, we're going to be using long division for this. So like this. So 3.21, 1.07, right? But I have good news. In division, if you have the same amount of digits after the point, as you can see, I have 2 after the point and then 2 after the point, you can just simply do what? You can just simply actually, at the end, don't use points. I will explain once I'm done with this. So like, I could just remove the points. Okay, so instead of this, I write 321 and then 107. Okay, so now how many 107s do I have in 321? Well, it's actually kind of clear here because if it's 1, it's too small. If it's 2, then you can add one more. So I can actually imagine that this is 3 times that. Why? Because 3 times 7 is 21. So imagine 3 times 7 is 21. And then this is 100. 3 times 100 is 321. So you can actually think about it a bit and then you can figure it out that this is just what? This is 3. Okay, so I have 3 of these in 321. Okay, now we're actually we'll be sure in a second because when we do the multiplication back, 3 times 7, that is 21, right? So 21. 3 times 100 is 100, so 121 is just what? Yeah, so 3 times 100 is 300, okay? We subtract, we get 0, so this is the result of the division. So you don't need actually points, so the whole thing becomes just what? 3 times what? 10 to the power of 2. And I think these 2 examples are enough to actually comprehend the whole topic. I hope that this video actually was helping. See you in the next one.